Hello and welcome to the LDAC booth at DAC 2019. My name is Piotr Skoszek and I will be talking about SoC simulation capabilities for mixed signal designs. In this demo, I will briefly talk about the challenges of verifying a design based on an analog mixed signal SoC. I will also take you through key features of Riviera-PRO and I will show you the process of simulating an analog mixed signal design using Riviera-PRO and Silvaco SmartSpice. Since a system-on-chip device usually contains an embedded processor, the ability to simulate such embedded processors and the embedded software is an important feature for an SoC designer. This can be achieved using LDAC QEMU bridge, which I will also talk about. Each year, SoC devices are getting more complex. They can contain embedded processors, programmable logic, and even analog circuits. In order to efficiently simulate an SoC design, we need a versatile high-performance tool. An RTL simulator is required for the programmable logic. We need another simulator for the analog circuits, and also a way of verifying the embedded software running on the processors of the SoC. Here we have a block diagram of a smart sensor based around an SoC device. Since our world is analog in its nature, we need some analog circuitry that will form an electric signal, voltage or current, that will change as the measured value changes. This analog signal will be processed and passed on to the programmable logic and the CPU. LDAC, in collaboration with Silvaco, developed a high-performance tool that lets you simulate such complex mixed signal designs. This design is split into three parts. The RTL part is simulated by the Riviera-PRO simulator, the analog part is simulated by Silvaco SmartSpice parallel circuit simulator, and the embedded processor is emulated using open-source CPU emulator QEMU. Signals from QEMU are passed to Riviera-PRO using LDAC's QEMU bridge. The whole process can be managed from Riviera-PRO graphical user interface. Silvaco SmartSpice is installed along with Riviera, and the simulation results, also of the analog part of the design, can be examined using Riviera-PRO debug features. Riviera-PRO is a high-performance tool capable of simulating all sorts of designs. It's the fastest VHDL simulator on the market. It has full VHDL 2008 support. It supports System Verilog and System C and mixed signal designs, and also includes some advanced debugging tools such as code coverage, waveform, plot and image viewers for visualizing large arrays of data. Riviera-PRO uses Silvaco SmartSpice circuit simulator for the analog part of a mixed signal design. SmartSpice is an advanced tool with support for industry-standard netlist formats such as Berkeley Spice, H-Spice, and Spectre. It's a parallel simulator, meaning that it takes advantage of multi-core CPUs, delivering almost a linear speedup as the number of cores increases. One of the supported input formats for the analog part of a mixed signal design is Verilog AMS 2.4. Here we can see a code describing an ideal operational amplifier. Note that Riviera supports Verilog AMS syntax coloring and code auto-formatting. One of the interesting language features visible on the screenshot that are supported by Riviera-PRO is instantiating SPICE devices directly in the Verilog AMS code. Other devices such as capacitors, transistors, diodes and sub-circuits are also supported. Another way of describing an analog device is to use SPICE netlist. This can be done directly in the Riviera-PRO HDL editor. Many advanced SPICE features are supported. You can instantiate Verilog modules directly in the netlist using SPICE buses to connect vector ports. You can use IBIS models to accurately model I/O buffers based on voltage current curves. You can declare parameterized subcircuits, and also worth noting is that Riviera-PRO allows simulation of designs that are purely analog. LDAC developed a QEMU bridge that enables the user to simulate processors embedded in SoC devices using open-source processor emulator QEMU. The LDAC QEMU bridge is a System C application that connects the QEMU emulator to Riviera-PRO simulator. Currently, QEMU bridge works with Xilinx Zinc 7000 and Zinc MPSoC device series. The connection between Riviera and QEMU is performed by remote ports. Remote port is a device visible in the Linux device tree. It's controlled by a driver, and the application running on the embedded processor is used to transfer data to and from Riviera-PRO simulator. The configuration and connection of the LDAC QEMU bridge is done in three domains. In QEMU, it requires adding Xilinx QEMU co-simulation device tree overlay to the user device tree. In System C, it requires connecting and mapping addresses between the processor and the FPGA. And in Riviera-PRO, it requires connecting the ALDEC AXI BFM to the HDL design. The ALDEC AXI BFM is a module developed by ALDEC to support simulation of custom IPs using the AXI3, AXI4, and AXI4 Lite interfaces. The most convenient way of creating simulation files for QEMU is to use the ALDEC Zinc PS IP core, which already contains all the necessary instances of the ALDEC AXI BFM connected to the AXI interface. I will show you a working example of a mixed signal design. Here we see the analog part of the design. This is basically a generator of a square wave, and the generated frequency depends on the value of the C1 capacitor. Its capacitance changes over time. The output of this generator is passed on to a frequency meter. The connection to the frequency meter is done using a connect module. The insertion of connect modules is performed automatically by Riviera-PRO. The simulation is already initialized. Here we can see the hierarchy of the design. As you can see, parts of the design are described using a SPICE netlist, and another parts are described in Verilog AMS 2.4. Both of these methods can be mixed in a single design. Here we have the voltage on this capacitor. As you can see, it keeps charging and discharging, and the number of these charge-discharge cycles are counted and then passed on to QEMU. And an application running on the QEMU records the highest and the lowest value from the sensor. Done. This concludes my presentation. For more information, visit our YouTube channel or go to our website at aldec.com.